Hello, welcome to this video all about formulae and how to substitute and rearrange. We'll start off by looking at substitution for formula, but before we do that it would be a very good idea to understand how to create a formula from seeing like a worded example. So for instance, if we had something along these lines, let's just change this, just make it a bit smaller. Okay, so something along this line, it says 10 subtracted from 9 times a number is the same as another number increased by 5. So there's lots of words going on here. So just take a second to try and take in what this is saying. Okay, so from this, what we're going to try and do is create, in terms of like algebra and formula and making equations and things like that. We're going to try and do this. So it says 10 subtracted from 9. Okay, but it also says 10 subtracted from 9 times a number. So 9 times a number is like a number that we don't know. Here's 9 times a number, so we can say a number that we don't know is like x or y or any other letter that we choose, usually x. So 10 subtracted from 9 times a number, so we're saying 10 subtracted from this bit here. This 9 times a number, we're subtracting 10 from that, so it's like 9x take away 10. And where it says is the same as, these are words that we're going to that need to be understood as things like equals. So the same as means equals, or exactly the same as, things like that, equal to, identical to, things like that we'll use as equals. And there are various words that you'll need to come across, and you'll see in lots of examples, especially from the downloadable books and things like that, where you can have a bit of a look through. But anyway, so 10 subtracted from this 9 times a number, i.e. this bit here, is the same as another number increased by 5. So another number suggests that it's different to this number here. So another number, it means we're going to need to use a letter. So another number increased by 5 is the same as this. Another number then, so y increased by 5, that means add. So we're adding 5 onto another number. So there we go, we've made a formula from a worded example that's actually quite complex to try and decipher, especially if you look at the separate bits. I mean, 10 subtracted from 9 would be like 9 take away 10, but 10 subtracted from 9 times a number is 9x take away 10, as we done. So it's quite useful to have a bit of a practice at those. So it was worth having a little talk anyway. So now we're gonna look at some substitution. Okay, so substitution, and what this means is we start off with some sort of formula. So let's write a formula out, such as P equals 2L plus 2W. And before we start doing the substitution part of this, it's worth seeing where this comes from. So this actually stands for perimeter equals 2 times the length plus 2 times the width. And this is of a rectangle. So if we were to have, I don't know, some sort of rectangle here, okay, and we say that this is the length and this is the width. Obviously this length here and this length here are the same, and then the two widths are the same. So we're saying the perimeter, i.e. the distance around the edge, is the length plus the width plus this length plus that width. So that's 2 lengths and 2 widths, which is where this comes from. So any perimeter equals 2 lengths times 2 widths. Sorry, add the 2 widths. Okay, so the substitution part of it is basically if I say, well, this is the formula for the perimeter for any rectangle, but I'm going to tell you that I've got a particular rectangle in mind that has a length of 2 and a width of 4. So the substitution part means taking this 2 and replacing it in the formula, replacing this L with the 2, and also this width, we're going to replace the W with a 4. So what this ends up being is 2 times by this length, which we said was 2, so I'm just substituting or replacing that, plus 2 times by the width, which was 4. so again substituting that part. And then we can find out the perimeter. 2 times 2 is 4, add 2 times 4 is 8, and then 4 and 8 is 12. So the perimeter would be 12, and this may be centimeters or millimeters. I haven't really specified in this case, but it's really important to not forget the units in these examples. Okay, so that's some substitution. Substitution can also be in various other ways, or other types of examples. So for instance, here's the area of a circle. So area equals pi times r squared, and if I said that the radius of a particular circle is 2, then we're going to substitute this in for the r. So it says a equals pi times by 2 squared instead of the r. So it's not just the r squared, now we're doing 2 squared. So then this would be pi times, well, 2 squared is 4, so pi times 4, and then if we were to work that out on the calculator, then it would come out as 12.6, and this may be again in centimeters squared or meters squared or something like that, some unit of interest. Okay, so substitution, fairly straightforward, just replacing unknown quantities with quantities that we now actually know. Okay, so now we're going to look at the second part of this, which was we've done the substitution. We're going to look at rearrangement and how to rearrange a formula and what that actually means. So we'll start off with a formula that looks relatively simple. P equals h plus 4 has no meaning whatsoever in this particular case. But what we want to do is rearrange this formula to a different order. And in this particular case, I would like to make h here the subject of the equation. What we mean by or the formula, that what we mean by the subject is that I would like to get h equal to the rest of it, i.e. we don't want anything else on the same side of the equal sign as the h. And in this case, you can see that the h here has a plus 4 that we don't want. So how do we do that? Well, you can consider it as like a balance scales. It's the same as how to change the subject of an equation. Rearranging a formula is pretty much the same thing. So what we're trying to do is we can consider it as like a balance scales. So here's a very basic drawing of a balance scales, and we're saying that P equals h plus 4, and we're saying we don't want that plus 4, so we're going to take away 4, i.e. do the opposite on both sides, so that cancels on this side. So what we end up getting is P take away 4 equals h, and here we've got h as the subject of the formula. We've rearranged the formula to make h the subject there, and that creates P take away 4. Okay, so we'll look at another example because that was fairly quick and straightforward. Okay, so something along the lines of x take away 2 equals 7h plus 4, and we want to make x the subject this time. So first thing to do is find the x. There's only 1 in this case, but it is really important to just scour the rest of the equation just to double check that we haven't got any more x's, but there's the x, and we want to make it the subject, which means that we need to get rid of everything else on the same side of it, which basically is this minus 2. So we want to remove that minus 2. How do we remove minus 2? By adding 2. But we add 2 to both sides, don't forget that. So what we end up doing here is having x on the left, because that minus 2 and the plus 2 cancel out, and on the right hand side we have 7h plus 4 and then that new plus 2, and we can join these bits together to simplify, and that creates 7h plus 6, because 4 add 2 is 6. Okay, so that's how we do another very simple one like that, although it looked a little bit more complex. So the very last rearrangement we're going to look at is slightly harder, which is something along these lines. Y equals 4x plus 12 all in brackets squared, and we want to make x the subject of the formula. So this one becomes a lot harder. they can actually become even more hard than this, but we'll concentrate on this one for now. So 4x plus 12 squared in brackets, which those of you that may have noticed already, that does actually become a quadratic. Some people think the way to go about this would be to multiply out these brackets, so 4x plus 12 times by 4x plus 12, that's what the squared means. But then we're going to end up with a quadratic, and it doesn't actually help. So the way we're going to do this is identify the x, and then say we're going to follow a set of rules that allows us to get this x on its own. And what we mean by that is basically the acronym BIDMAS, but more importantly we're going to go backwards with BIDMAS. And what that means is I'm going to start with the s and say, is there any subtraction? No. Is there any addition? Yes, there is. There's a plus 12. However, it's really important to consider where this plus 12 exists, because we can't just take this plus 12 out of these brackets, because it's locked in with this squared. So anything like fractions and powers, maybe square roots and things like that, will lock in some particular terms. So it might not be, although we get to the a and we say, right, okay, we'd love to move this plus 12, we can't yet because it's locked in with this squared. So basically what happens is we go through a, m, d, we can't do any of the multiplication or division, removing that because of that 4, because again it's locked in within these brackets and this power. So then we get to the I, which is indices, and we say, right, okay, we found this 2 and we want to get rid of that 2. Can we do it? Yes, because that's the only thing that's locking in everything else. So how do we get rid of this power of 2? Well, because it's a squared, the opposite of squared is square root. So that, if you agree, says that we square root the left hand side and then we square root the right hand side. But when we square root the right hand side, it cancels that off, which is exactly what we're after. So we end up with 4x plus 12. And then we start the whole process again, i.e. backwards BIDMAS. This way, subtraction, no. Addition, yep. This plus 12, well, that actually now exists on its own. Nothing's locking it in, so we're going to remove this plus 12 by taking away 12 from both sides. Okay, so we've got this square root of y, and then we're taking away 12. But that take away 12 is not within that square root of y, it's separate to it. So it's really important not to extend this square root over the minus 12, because that is separate. Anyway, so on the right hand side, we've got this plus 12, taking away 12, they cancel out, and we end up with 4x here. And then the last step is to divide by this 4, because that is timesing, so we divide 4 on the left and the right. And on the left hand side, we're going to divide 4 by the whole lot. Everything divides by 4, so we put a nice big line there and divide it by 4. And on the right, that 4 cancels with that, and then we get just an x. So we get x equals root y, take away 12, all over 4. And that's how to rearrange. We're going to use this backwards BIDMAS type arrangement with considerations to what numbers and letters and terms are locked in by other functions such as squaring and brackets and square roots and things like that. There are going to be some harder examples on another video and topic which is dedicated to looking at these particularly hard examples. Thanks very much. Laura, so here's a single bracket expansion. Are you happy to give that a go?
Yeah, would it be 6x plus 5?
No, actually, it's not quite that. Not quite right. Do you want to give that another go?
Oh, was it 3 times 5 as well?
Yeah, 3 times 5 as well.
So it'd be 6x plus 15.
Yeah, perfect. Well done.